Today we're going to talk about indirect measurement, which is using proportions of similar figures to measure objects that are either really difficult or impossible to measure directly. So, for example, if we were to try to measure a building, like the height of a building with a yardstick or a measuring tape or a ruler, it would be almost impossible. But we can use indirect measurement and the proportions created by similar figures to figure out those measurements, to measure indirectly. So let's look at example number 1. It says a student is 5 feet tall and casts a shadow that's 15 feet long. Whoop, that looks real janky. There you go, 15 feet long. A nearby tree casts a shadow 75 feet long. So let's say that this is our tree. Okay, and then its shadow is all the way across 75 feet long. So essentially what it is we've created these two similar triangles. We're assuming that the person and the tree are standing at the same angle, which for everything, all our intents and purposes, this chapter they are. And now we can set up a proportion of similar figures. We have this smaller triangle and this larger triangle. So I can say, for example, the height of the person over their shadow equals the height of the tree over its shadow. So 5 over 15 equals x over 75. And now I can use cross products or common multiplier. Any of my methods that I've used in the past to solve these proportions, I can use right now. So I'm going to say, well, I know that 15 times 5 is 75. So 5 times 5 would be 25. So x would have to equal 25 feet. And if I plug that in here for the height of my tree, it makes sense because the 5-foot person, their shadow was 3 times their height. So what's 3 times 25? 75. On the next one, it says a school 60 feet high casts a 40-foot shadow. So the 60-foot school casts a 140-foot shadow. A nearby telephone pole casts a 210-foot shadow. Find the height of the pole. So the height of the building over the shadow of the building equals the height of the pole over the shadow of the pole. So before I go and try to solve this, I'm going to see if I can simplify this fraction because these are really big numbers. So I know that they're both divisible by 20, which gives me 3 over 7 equals h over 210. So now I can do cross products, or I know that 7 times 30 is 210, and 3 times 30 is 90. So the height of my pole would be 90 feet. And then this last one, okay, sometimes they might be set up like this, so you have to kind of think about, okay, well, what if they're attached right here, if I kind of like clipped them apart in the middle, and then I took that top larger triangle and took it and kind of like rotated it down, so it was positioned the same as my other triangle, the 30 would go here, and the x would go on the bottom. So now when I'm setting up my proportion, I can say the left side over the base equals the left side over the base. So I'm going to go ahead and reduce this to make it 4 over 5 equals 30 over x. And now I can do my cross products. 5 times 30 is 150. X times 4 is 4x. So I know that I'm going to have to come over to the side and do 150 divided by 4 to figure out what x is. 4 goes into 15 3 times, that's 12. 4 goes into 30 7 times, that's 28. And 4 goes into 20 5 times. And that gives me a remainder of 0, so I'm done. So 4 over 5 equals 30 over 37.5. And that would be my final answer.